Quantile loss. Let us learn about quantile loss, which is a loss function with a different characteristic from all the loss functions we've learned till this point. So whichever loss function we learned till this point, they were all trying to predict the mean or the median. This is what we had generally seen. But quantile loss is different. This loss function, it is used whenever you are interested in predicting a quantile instead of predicting the mean. So quantile means median is also a quantile, it is 50th percentile, or maybe you want to predict 90th percentile. This is where quantile loss comes in. Let us take some other loss functions as example and understand how this is different. Then we'll see what is the loss function and all those details. First of all, if you take, let us say, mean squared error. In the mean squared error, what did we learn? This is used whenever you want the model to predict conditional mean, that is expectation of y given x. This is when you use mean squared error. What about mean absolute error? Mean absolute error was used whenever you want the model to predict conditional median. Conditional median means 50th percentile. This is when you used mean absolute error. But sometimes what happens is we don't want to just find the central point. Instead, if this is the central point, we don't want to simply find the central point. Instead, we may want to find 90th percentile. If this is from 0 to 100, we may want to find 90th percentile, or let us say you want to find 25th percentile instead of finding median, which is 50th percentile. In such situations, you go for quantile loss as your loss function. I'll give you an example. If there is an engineering entrance examination and you want a model which will predict what score will get you to 90th percentile. If you want this output to come out from the model, then quantile loss could be a good option, right? What we'll do is, we'll first go through the mathematical function, that is the loss function, and then we'll explain how it is helping us find out the quantile, a particular quantile, instead of the median, okay? Then this loss function's purpose will be very clear. First thing you have to do is, you have to fix what quantile you want to find. So for that, you will have a value tau. Tau will take values from 0 to 1. What is the significance of this value? If your value tau is equal to 0.5, that means you want to find the median, that is 50th percentile. If your value of tau is equal to 0.9, that means you want to find 90th percentile. If your value of tau is equal to 0.2, that means you want to find 20th percentile. So this is the logic behind this value tau. So the first requirement, if you want to use quantile loss in order to predict some particular quantile, is that you should fix the value of tau. So once you got the problem statement, you know what percentile you want to find out. Accordingly, you fix the value of tau. Next question is, once you fix the value of tau, what is the loss function? In order to understand loss function, first you want to know what is residual. Residual is y minus y cap, where y is the actual value, the expected output, and y cap is the predicted output. That is, if you have an input x, y, in which x is the input and y is the expected output, whatever value you actually want, the true value, then if you pass this x as the input to your model, the model will find a prediction which is y cap. This is the output of model. This y cap may not have the exact value of y, the expected output. Instead, the value of y cap may be slightly differing from y. So whatever is the difference between y and y cap, this is your error or residual. What is your aim? You want to decrease the error or residual so that your model will give you perfect outputs. So your residual is y minus y cap. Considering the residual, what is your loss function? Your quantile loss function, L tau of r, can be written as tau into r, whenever the value of r is greater than or equal to 0, and it will take tau minus 1 into r whenever the value of r is lesser than 0. Let me erase these things off. So when you see this value, this is one way of expressing it. That is, whenever the value of r or residual is greater than or equal to 0, residual is positive, then you use tau into r. Whenever it is negative, you use tau minus 1 into r. There is another way of representing the same thing. The other way of representing is, you can say it is simply maximum among tau into r and tau minus 1 into r. What is the logic behind this? How can you rewrite it as maximum of these two? The logic is, if your residual is greater than 0, then the value tau r will be positive. But what will be the value of tau minus 1 into r? You already know tau is something between 0 and 1. So if your residual is positive, your tau minus 1 will be negative, because tau is always between 0 and 1. Tau minus 1 will surely be a negative value, which means if residual is positive, tau minus 1 into r will be negative. So automatically, if your residual is positive, then tau r will be positive, tau minus 1 into r will be negative, which means tau r will be chosen as the maximum value. That will be the larger value. What if residual is less than 0? Then r will be negative, tau into r will be negative, because tau is a positive term. Tau is between 0 and 1. So tau into r will be negative, and tau minus 1 into r will be negative into negative, which will be positive. So whenever your r is less than 0, your tau into r will be negative, tau minus 1 into r will be positive, which means this will be the maximum value. So automatically, if you put maximum function, the right one will be picked. Otherwise, you can specifically say that whenever your residual is greater than 0, you will use tau into r, and whenever your residual is lesser than 0, you will use tau minus 1 into r. Next question is, what is the intuition behind this? What is the intuition behind choosing these particular terms as the quantile loss function? This is the most important part of this lecture, because if you understand this intuition, it is easy for you to understand quantile loss. You will all automatically understand what is quantile loss. Intuition is this. First case, whenever residual is greater than 0. That means your prediction y cap, this is lesser than y. Why is this? Because your residual is y minus y cap. If this is greater than 0, that means y is greater than y cap. Your prediction was smaller, right? Whatever you predicted as y cap, that value was smaller than the expected value y. So your penalty will be proportional to t. T means tau. Whatever penalty you are going to apply, that will be proportional to the value tau, because you are trying to find whatever percentile that is mentioned in tau. But in case y is lesser than y cap, that means whatever you predicted, that value went above the actually expected value. In this case, you are going to apply a penalty that is proportional to 1 minus tau. Why is 1 minus tau? Because this r is going to be negative. That is why I wrote 1 minus tau here. So the logic here is, underestimation and overestimation are penalized differently. Why did I say that? Because there are two cases. One is, if this is the value of y, if this is your number line, and somewhere here, this is the actual, let us say, predicted value y. Predicted value y is somewhere here. Then, if you are overestimating, if your value y cap is somewhere here, then you will penalize in one particular manner. And if your y cap is somewhere here, it is a lower value, then you will penalize in a different manner. That is why you have these two cases and these two formulas. This is the logic behind quantile loss. I'll just show you with an example. The logic of penalizing differently is, let us say your value of tau is equal to 0.5. I'm just trying to show you what happens when you penalizes underestimation and overestimation differently and equally. In case your tau is 0.5, what happens? Both of these will have equal penalization. That is, if r is greater than 0, your loss function will be 0.5, that is tau into r I am doing, 0.5 into the value of r, which will be 0.5 r. This will be the actual loss function's value. What if your tau is having, let us say, something like 0.9? In this case, okay, I'll first show you the difference. This is when r is positive. What if r is negative? That is, I'm showing underestimation and overestimation. If r is positive, that means you are having underestimation. If r is negative, that means you are having overestimation. Why is that? Because your residual is y minus y cap. If r is positive, that means y is larger, y cap is smaller. You did underestimation. You got a smaller value than actually required value. So whenever r is positive, that means you did underestimation. Loss is 0.5 into r. What if r is overestimation? That is, r is negative. That means y cap is larger. Then it is overestimation case. You will use this formula. Tau minus 1 will be minus 0.5 into r will be a negative value. So finally you have 0.5 times mod r, that is positive side of r. Both these cases you applied same penalty when your tau is 0.5. That is the median case. What if your tau is 0.9? You are trying to find 90th percentile. In that case, if your tau is 0.9, then in positive case, that is, whenever you are doing underestimation, you will do 0.9 into r. This will be 0.9 r. This is the penalization whenever you are doing underestimation. If you do overestimation, this will be minus 0.1 into minus of mod r, because r will be negative. That will be 0.1 into mod r, right? This will be the value. What did you understand from here? The point is, whenever you are overestimating, the penalty is very less. It is 0.1 times the loss. But whenever you are underestimating, penalty is very high. What happens then? If this is your number line, if this is your 90th percentile value, whenever you underestimate, I'm telling you, I'm not penalizing you. You may underestimate if you take some value like this. If it is an I'm penalizing you more. 0.9 times I'll penalize you. So if you underestimate, I'm saying you there is a greater risk. Whatever be the loss that you are causing, over that loss, I am going to penalize you 0.9 times. That is a very high penalty. Because of which, what will you try to do? You will try to come towards this point of overestimation. That is how you are driving it from the median point towards the 90th percentile point. Whenever you do overestimation, I am telling you the error is only 0.1 times of the error that you caused. I am actually decreasing the penalty on you. So what will you do? Automatically what you will do is, you will try to either find out the actual value or overestimate. So you will try to move towards overestimation because overestimation is safer here. This is how you are driving your model towards the 90th percentile instead of staying on median. This is the logic behind quantile loss. So the next thing is, how do you find the derivative of a loss function? See, there is a reason why I'm trying to find derivative every time, because in machine learning, if you want to apply it on a model, you will have to use, let us say, some optimization. So if it is gradient descent, you should clearly know how to find gradient. Otherwise, it doesn't make sense. That is why every lecture I'm trying to show you how exactly to find the gradient. Okay. What I'll do is, let us try to find out gradient of both these cases in case of quantile loss. How do you find gradient? You want to find del L by del y cap. That is, with respect to the prediction, you want to find the gradient. So what is the value of this gradient? This will be minus tau whenever r is greater than 0, greater than or equal to 0, or equal to 0 won't be there. Okay. Then what about 1 minus tau will be the value whenever it is less than 0. How did I get these values? It is simply application of chain rule. So I'll just show that as well. Let us say I want to find del L by del y cap. What will I do? I will apply chain rule. I'll say del L by del R, R is the residual, into del R by del y cap. So what will I get as the value here? My R will be y minus y cap. If I take the derivative with respect to y cap, answer will be minus 1 because minus y cap is here. So this will be minus 1. This part will be minus 1. What about del L by del R? L is tau into R. If I differentiate with respect to R, I will get tau. So this will be tau into minus 1, which will be minus tau. This is what I got here. Similarly, the same logic, you will get minus of tau minus 1, which is 1 minus t. That is here. So that is how I found out the derivative. What did you find out here? One more thing. Why did I remove r equal to 0? Because at r equal to 0, derivative is not defined the same way it was for MAE, mean absolute error. But in all other places, you have the derivative. Okay. So one more point, this asymmetry that you can see in the gradient, this is what actually is driving the predictor to align with the chosen quantile. Whatever is your quantile, let us say you want to find 90th quantile or 20th quantile or whatever, this particular asymmetry, the asymmetry that is there in the gradient, this is what is actually driving it towards this particular quantile. I already showed it to you here, that how it is driving towards that quantile point. So one more thing. Let us say, suppose you want to predict the 90th percentile in some particular score. Let us say entrance score or something. So if you underestimate, what did we learn? Whenever you underestimate, you get penalized heavily with a weight of 0.9. Similarly, if you overestimate, you get penalized very less. Let us say something like 0.1. So this is how you were driving it towards 90. So what happens? So the fitted line, or let us say fitted curve, whatever, that will move upward to ensure 90% of actual points lie below it. This is the logic, right? So because it does that, you will automatically find out the line at the 90th percentile. This is how quantile loss is working. When do you use this? You use this whenever you want to find some particular quantile value instead of the central point, right?